Welcome to the Maths Made Easy tutorial on real life graphs. So in this video we'll be looking at graphs that depict real world situations and we'll specifically be looking at their gradients. Now in the graphs we'll see today, all of the x-axes are at some form of time, so it might be seconds, it might be days, but whenever you have a graph with something plotted against time, the gradient will always represent the rate of change. So let's look at these graphs A, B and C, starting with A. So we can say that the gradient of A, which we find from taking the height by the width of any section of the graph, like that for instance. So the gradient, or we can say m for short from y equals mx plus c, is the water flow per second. So we can say that that is the flow rate. And that will be measured in litres per second. And then moving on to B. In B, we have the cost in pounds against the time in days. So M would be the cost per day, and you could measure that in pounds per day. So finally then, if we look at C, the gradient this time is velocity divided by time. Now if you know your formulas, acceleration is equal to velocity divided by time, so therefore M, or the gradient, is acceleration. Now the units for acceleration would be meters per second, or meters per second squared. So as we've said before, the gradient represents a rate of change when we've got time on the x-axis. So we could say that in A, the gradient represents the rate of change of water flow. In B, the gradient represents the rate of change of price. And in C, the gradient represents the rate of change of velocity, which is also known as acceleration. So if we move on then, let's have a look at some example questions. So the first example then, Sammy is running a 100 metre race. His distance from the finish line is plotted on the distance time graph shown. Calculate his average speed between 4 seconds and 12 seconds, give your answer in metres per second. Well, when we've got distance on the y-axis and time on the x-axis, the gradient, distance divided by time, will be the speed. So, to find the speed between 4 seconds and 12 seconds, we need to find the gradient at that point. And the line is curved, so as you can see, all we've done is we've just drawn a straight line between those points on the graph to sort of find the average in that time span. So to find the gradient, all we do is we form a right angled triangle from this sort of average line that we've drawn. So we'll draw a line across from the base of the triangle, and we'll draw a line up to form the height of the triangle. Now the gradient we'll get from dividing the height by the width. So that's the distance span divided by the time span. So the time span is pretty easy to work out, it's just 4 to 12 seconds, so that's 8 seconds in total. Now the distance span is a bit harder to work out. Now we've got 5 small boxes per large box, and the increments go up in 20 per large box. So that means that each small box is 4 meters, and we go from this point here, which is 3 tall, so that's 12 meters. And if we go right up to the top, the value here, well, that's 1 box less than 80, so that's 4 less than 80, so that's 76. So therefore the distance span is 76 minus 12, which equals 64 meters. So to find the speed, all we do is we divide 64 by 8, so that's distance divided by time, and that gives us 8 meters per second. So the final example then, the descent of a high altitude weather balloon from 40 kilometers above sea level is displayed on the graph shown. Work out the rate of descent after 5 minutes, give your answer in kilometers per minute, or km/min. Okay, well, to do this question, we're going to need to draw a tangent to the graph after 5 minutes. So first of all, go up to the point on the graph that is 5 minutes in. So we need to draw a tangent from this point here. Now a tangent is a line that touches the graph at a single point and has the same gradient as the graph at that point. So our line should look something like this. So what we need to do now is form a right angled triangle in order to calculate the gradient. So the gradient, which we'll get by dividing the height of this triangle by the width, will be our descent rate. So let's draw a line across from the end of the triangle, so like that, and now we can just add the height for completion. So in our triangle we've got a span in time of 10 minutes along the x-axis, and that's because I'm using the whole of the grid to draw the triangle. The bigger you do your triangle, the more accurate it'll be. And then in terms of the altitude then, it starts at about 14 here, the base of the triangle, and it goes right up to a value of about 48 here. So the gradient, or in other words, the rate of descent, will be 48 minus 14 divided by 10 minus 0. So that comes out as 34 divided by 10, which is 3.4, and the answer wants to be in kilometers per minute. Altitude is already in kilometers and the time is already in minutes, so that value is in kilometers per minute. So our answer is 3.4 kilometers per minute. If you want to have a go at some exam style questions for the real life graphs topic, then why not have a go at our online exam? It's available through our revision platform. You'll find loads of different questions in this exam, a variety of different question types, and you'll get instant feedback on each and every one of them, which will allow you to keep track of the areas that you need to improve on. So if you're interested, then why not click the link below, it'll take you straight there.